Students, welcome back to the next part of the lecture number 26, and in this part of the lecture we will talk about CNN or convolution neural network. And we have talked about different names or different acronyms. So, these are the ones which I give you the full value. CNN stands for convolution neural network, RNN stands for recurrent neural network, then you can also GNN, generalized adversarial neural network, autoencoder, colonial map or self organized map, SOM, deep belief networks, DBN. You can also have hybrid deep neural network, or you can have deep transfer learning, DATL, or deep reinforcement learning. So many variants are there. The deep learning is a well developed techniques. So, what is convolution network basically? Basically, it is a type of deep learning neural network which commonly used in computer vision, image processing actually. And it is basically enables computer to understand interpreted images or any visual data. So, therefore, the second set of data 2D data is going to come into picture, correct, and it is a commonly used in computer vision, and it is a field of artificial intelligence that enables the computer to understand and interpret the visual data. But it is an extension of ANN. It is not completely different from ANN, but more additional features are added, and it can be used to extract the features from the images. That is a new thing. It can be used to autonomously extract features from the images or grid-like matrix data sets. Basically, we will talk about it how images are read by computer. For example, you have a visual data sets like images or videos where data patterns play an extensive role, very important role. Okay. So, that is why actually these networks will be more used widely. So, let us talk about that. How does a computer see image? Let us do that. So, I have used one of my old pictures, I was looking much more handsome than today. So, you can see that. So, now computer cannot read the image like that way. Computer reads the images by some pixel values, pixel elements. You can clearly see there are pixel elements which are very bright, some are dark, some are grey, right. That is what you see, correct. So, now how do you put this, which one is dark, which is light? Computer does not understand dark, light, right. So, you have to put some numbers, and as you can see here I can read some numbers. Blacks are actually all 0, you can see that 0 or close to 1, and the whites ones are 200 something. So, basically we use a scale between 0 and 255 as a intensity scale. So, whichever is more intense, that will have a higher value. So, the one which is very bright is a 252, you can see there, and I can see here 252 here, correct. One which is little dark as a 210, or darker one as 127, and very dark one as 0, correct. You can have also other values like 1, 12, like that. That is how the computer sees the image. Okay. You know it, but you have never thought like that, right. So, now we can put this whole image into 2D data, that is called pixel intensity values. You can see that this is a 2D data, that is nothing but a matrix, right. In a matrix you have columns and rows. So, these values are put there or placed there, correct. So, image is just a matrix of numbers between 0 and 155, that is what we call any RGB image. Basically a color image we call a RGB image, it is nothing but a matrix of numbers. So, once you know this, then you can understand what is CNN or convolution network, whatever it is. Okay. This is very important aspects, and here it is 1080 by 1080 to 3, that means 1080 pixel element in x direction, 1080 pixel element in y directions. Okay. In the depth direction you have 3 elements. This is basically RGB image, RGB red, green and blue, basically color image. The question is, once you know this, okay, I hope you understand that. So, you can convert any image. If suppose you have a photographs, printed photographs, you want to scan and convert into that. Actually computer does the exactly same way. When you scan it, you are converting the intensity map into these numbers. Okay. So, these numbers are basically telling you intensity map basically. Intensity map means intensity values, pixel intensity values. Now, When you buy a camera, you get 6 megapixel, 12 megapixel or sometime more than that. What does it mean? That means the image can have maximum 12 to the power 10 to the power 6, 12 to the power 6 pixels. That is why it has got 12 megapixel. Okay. So, 12 into 10 to the power 6, 10 to the power 6 is megapixel elements. Okay. That is what is called pixel element. Okay. That is what is called the resolution of the camera. So, that means one image can have maximum this many elements. That is a huge, right, 12 millions. So, question is, can I just do classification on this one, you see this values, I think 1166400 long image vectors. So many image vectors are there. Okay. Can I do the classification on that? Obviously, answer is no. You cannot do this, because this will take you many years. Instead, you can use this image as a spatial structure, or you can learn from patches. Okay, that is what we will show you, how we can learn from patches and then build them up. Okay, instead of using large image, you can use patch, small patch, and then re-roll over. Okay, let us learn how it can be done. I hope this is a very important slide. I wanted to explain to you how it is important to note that. So, it's world of full of images. Material science is, we are always talking about microstructures. Microstructures are full of images, right? And then how do you do this image processing using CNN? That is a big question. Well, how does human do? Well, human has an eye, right? Using an eye, we can detect a particular shape, or we can detect a particular color also, right? And we have this is structure of eye. I do not want to give a lecture on biology. This is standard class 10 biology images. So, you can have layers of neurons which can detect pixels, edges, shapes, primitives, scenes also. Scenes means video. Okay. So, there are different parts of that. You can see that it is shown here. I can read. You can have optic, radiations, lateral, nucleus. These are different paths. From the eye, the images, the information comes, is processed by the brain. That is how it is done. Then you can have a rod and cone cell, which can detect your capability to see the color images, and this is typically known. This you can see from this site, okay, iit.edu at NPR, Dr. Jennifer's, is nicely given. So, how does this neural network will function, okay, in this case? Well, as you, this is exactly same what we have discussed in the last. So, this is a neuron, two neurons are shown and they are parallelly connected. As you see here, these are my input values. Okay. We have different input values V1, V2, V3, they are all features. They can be colors, different colors, they can be shapes, they can be attributes, that is what we discussed, right. The shapes, edges, pixels, primitives and scenes, they are the layer of neutrons, correct. So, you can do that, and they are actually then multiplied by weights, W1 for V1, W2 for V2, W3 for V3, sum it over, then you can actually do this leaky integrate, leaky ReLU. Remember that I gave a leaky ReLU functions, they can do that, and then you can get a output, right. That is what is done. So, neurons connected into circuits that can give you lot of learning properties, simple primitives arranged in simple repetitive extremely large networks, and you can have large number of neutrons, okay, that is what 10 to the power 12 connections are possible, which is called a quadrillion connections, 10 to the power 12 connections possible in the human brain. That is why human can see objects much better. So, what is the idea here? Well, idea is very simple, and let me explain to you. And CNN, let us first look at CNN architecture. I will go back to the board and then explain to you, then come back here, what is the idea. CNN architecture is very important. From architecture, we can learn various aspects of this. So, what does it contain in the architecture, and how this architecture will be used to detect or to predict or rather process images, that is what it is. Okay. So, first of all, let me draw this architecture. So, CNN, I write down also convolution. right, convolution neural network. I hope you know what is convolution. If you do not know, we will explain to it also. So, what we have is input. Input is nothing but a image, right. Image is what is used, input. Image can be a microstructure, image can be a macrostructure. Then this image is basically processed. After that process like that way, I showed you the numbers. Then you put some convolution layers. These are convolute the images. After that, you have put another layer which is called pooling layer. And then you have a dense layer which will reconstruct the images. So, pooling layer is basically going to, so because of convolution, the amount of data will increase a lot, and you have to reduce the dimensionality, pooling layer is used. So, then you have a dense layer. I think I should use capital letters so that you can see from distances. And finally, you get an output. That is what is the basically structure of CNN. Okay. So, now the question is what these layers do, each of these layers, that is what we will discuss. So, first the image is processed the way I told you, image will be processed in a very simple way, and that is this will be like a matrix to a matrix or rather 2D data, and then it will do convolution. Convolution does what? It applies filters or basically kernel, very simple, right. It is applied filters or kernel to the input image to extract features. So, basically it applies filters or kernels. Kernel is a new word, but you must have heard kernels to extract features. Automatically it will extract features. That is what it does. And pooling layers is downsample the image to reduce the computation time, downsample. Okay. This will downsample the image. Downsample may reduce the dimension, downsample the image. Why? To reduce computation. Because once you apply filter, and I will talk about why this will increase the data, correct. And so therefore, that is fully connected layers makes the final, so that fully connected layers can, a dense layer actually, that is what a fully connected layer can give the output. Now, the question is what is this filter or what is this convolution layers do? That is basically the whole aspects. So, let me explain from the slide, and again I go back to the board and do that. So, idea is what? You can use patches of input to neurons in the hidden layer, that is what is shown here. So, what do you do? Suppose this is like 4 by 4 cross pixel elements, I have 4 pixel elements on the row, and each column also has 4, so 4 by 4, okay. So, then what happen? we connect this 4 by 4 patch of the input to a neuron in hidden layers. Hidden layers, you understand, input layer, hidden layer, output layer, right. So, we put these patches to the hidden layer and then we roll it over. Okay. So, connect patch in input layer to a single neuron and we can always slide the window. This window can slide over. Okay. So, therefore, you do put this patch 4 by 4 patch to a hidden layer, do the calculations, do everything whatever calculation possible. So, that will reduce the computational power or whatever, because it is difficult to handle such a large number of pixel elements at one go. So, then once it is done, this will be then shifted or this will be slided to the next layer, next one, and that is how things can be done. So, question is, can you weight the patch to detect a particular features? That means, can we assign weight to each of this patch? Weights, we are putting in any neural network, as I showed you W1, W2, W3, okay, to the each of these. So, can you also do that? Yes, you can do that. That will determine whether a particular feature is more important, less important. So, let me explain a very simple way. This is what is used, much simpler way than that, what I shown in the slide. Okay, let us take a very simple example of that. I will keep this convolution part only. Here on the slide on the right side, I will try to explain the concepts. Well, it's imagine you have an image which is a cuboid. Okay, let me draw a cuboid. All of you should know what is a cuboid. That is a cuboid, right. Now, it has length, breadth, width and the height, right. So, it can be represented by length, width, length is this, correct, width is this, that is the dimension of the image, correct. On the height is represented by channel, right, RGBs, red, blue, green. Why? Because as I told you, every image is represented by RGBs, right. And once you have RGBs, then you know the pixel elements very easily, right, values of each pixel element, whether it is 0, 1 or 25 or 255 or 250, 252, whatever it is, you can easily know that. So, now imagine, so this is a big image, correct, and it has these characteristics. Now, let us do the next step. What is done? What is the idea, big idea of this? Now, imagine this patch. Okay. So, we will come back to it here. Imagine a small patch of this image and run a small neural network called a filter or kernel on it. What is that? So, let me draw that. So, imagine a small patch. Okay. Small patch is like this. It will be 3D. Imagine a small patch like that, and so we can always didn't happen nicely, and it does not matter. So, imagine a small patch, this is a patch basically, like this. So, what do you do with this small patch? So, that is what we are discussing. So, this patch of this image, take a small patch, run a neural network on this. That is what we call as a filter or a kernel, and we get some output. Now, slide this small patch of neural network across the whole image. So, as a result, we will get another image with different widths, different lengths as well as depths, right. We have used, instead of using the whole image at the beginning, we are using a patch and use a neural network onto that patch, correct, and that we call as a filter or kernel, and this will give you some output, and then we slide over this. This is the novelty of this idea. Slide over this or the whole image. As a result, we will get another image with different. Once you slide over, we will get many images, and we collect it together, it will give another image. We will have different widths, heights, and depths. So, instead of RGB channels, we can have more channels, but lesser widths and the heights. And this operation itself is called convolution. Whole thing is called convolutions. Geometrical, this is what is called convolutions. Okay, and that is widely done in image processing. If the patch size is small or patch size is same as the image size, then it is a regular neural network, or otherwise it can be called other things. Okay. So, to give an example, convolution layer consists of a set of learnable filters or kernels having small widths and heights and the same depths as the initial volume, same depths as the RGBs. For example, if you have to run a convolution on an image with dimensions of pixels of 34 versus 34 into 3, 34 is the length, 34 is the width, and 3 is this RGB. R red, G is basically green, and B is for blue. All the images can be combined of these RGB scales, actually, you know that. So, then if possible to slide, the possible slide of filters must have a dimension A cross 3, 3 you cannot change obviously, and A will be always less than width or the length. It can be either 3 or it can be either 5 or 7 or 9 or 11, it will be always less than 34. Okay. So, during this forward pass, that is what you are doing. We slide, forward pass means you slide this small patch over the whole volume step by step, and that is why each step is called a stride, STRIDE, stride. When you walk, we take a stride also, and you know itself, whole thing itself is called basically convolution. Okay. So, mathematically what is a convolution? Or let us come back here. Here it is also shown in the same way. So, you have a filter size 4 cross 4, that means there are 16 weights, 16 different weights, 4 cross 16. Apply the same filter to this 4 plus 4 into 4 patches in the input, and then shift it by 2 pixels for the next patch. Remember this. So, this 4 by 4 patch is, we use it and apply neural network, find all the things, parameters as output, and shift it by 2 pixels. That means 2 elements. So, it will go to the next, it will go like here, from here to here, right, 4, another 4, like that you can actually slide it over. This patch can be slided over, and this whole operation is basically, once you do that, then you have to sum it over the whole image. So, advantage of this is that you are not applying your filter or the neural network over the whole image. You can decide how small patch you will use. You can use 2 by 2 patch also, that depends on your computational power, architecture, whatever you have. We can apply set of weights or filters to extract these local features. You can use multiple filters to extract different features, and you know we specially share parameters for each filters. So, these are all things you can always do with that. Okay, now you know regarding features, it can do high level feature detections. If I take this image which is shown on the left side, my own photographs, you can see nose, hair, mouth, spectacles, these are the features, right. You do not have to tell you, you can see and determine because you are a human. Computers can do that or not, obviously depending on the pixel values it can do. Hair has very high pixel values, 255 close to. Okay. So, nose has much lower pixel value. If you see the cars, it has 3 important features. One is your wheels, you can see, you can also see the headlights, and also you can see the windows. If you see the house on the right side, you can see doors and windows, right. So, identification of the key features in the image can be done simply by using these convolution networks, because you can use patches, right. That is why you can identify each of these. Now, talking about the weights, what we are doing, we can use set of weights, different weights for the hair, for the spectacles you can use different same kind of weights, but for the nose and the mouth you can use different kinds of weights, right. Similarly, wheels and the headlights, it can have same type of weights because they looks white or bright, but windows little bit less of that. You can say why not use these doors or all the rear view mirrors. Yes, you can do that also. These are all features, right. So, that is how actually features can be automatically determined. Now, mathematically how do the convolution is done? So, convolution is a basically mathematical operation, because you are getting 2 by the matrix data, or the image is converted to matrix of data, 2D images, 2D data points. So, it is a mathematical operation that allows to merging 2 sets of informations. Okay. In case of CNN, apply to input data always to filter the information and produce a feature map. This filter is called a kernel or feature detector. So, what is it is done? Let us say this is a feature or filter actually, you see 101, 010, 101, right. So, this is your image which is also 111 like that. So, what is a convolution? I multiply 1 with 1, correct, 0 with 1 0, 1 with 1 1, okay. So, now you can also 0 0, 1 1 and 0 1 1, okay. So, what you do, I write it this one here. So, 1 into 1 plus 0 into 1 plus 1 into 1, okay, that is in the first row, then plus 0 into 0 plus 1 into 1 plus 0 into 1, the third row 1 into 0 plus 0 into 0 plus 1 into 1. So, how many you get? This is 1, this is 1, 2, 3, 4, that is what you get. That is a convolution. This is a convolution mat. So, that means what? This filter is multiplying with this image matrix, but we are doing patches, we are not doing whole. That is the key features of CNN, and this convolution is done for every small patches. To give an idea, let's say this is image of a black and white image of a dog, right. So, you can use plus filter, minus filter. If you use a minus filter, output will look like a inverted image. That we all do, right. We always invert image, that is called minus filter. If you have a plus filter, it will be enhanced, these features will be enhanced, right. So, you can have different kinds of kernel possible. I give you few. If it is identity, you see one, only one is there, that is identity. It will be same as the actual image, right. Otherwise, you can use age detection, because age is what creates problem when you process images. You can see age detection as 1 0 minus 1 0 0 1 0 0 0 minus 1 0 1. It is a filter actually, matrix filter. You do not see anything here, only you see some edges, some the hair, the ear of this deer, you can see some part of that, right. You can also use sharpening. Sharpen one, you see 0 minus 1 0 minus 1 5 minus 1. So, this 5 is what is making the sharpen. You can have box blur also. All of you use this kind of processing techniques or kernels when you do image processing, but you do not realize. I see box blur has 1 by 9, this 1 1 1 cross 1 matrix. You can use Gaussian blur also. So, blur is something you can want to blur the images. In TVs or somewhere you see sometimes they show you image or video which is part is blurred. That is the filter they use to do that. Okay, so these are the wells you can do. So, now convolution neural network has many more features. We will talk about all these aspects in the next lecture, but let me tell you, it is very popular in social media, very popular network, because you are dealing with images, you are dealing with videos, and that processing task has to be very important. FNN cannot be scale up to images video processing task, it cannot be. The FNN means the normal ones. CNN can be tailored for any images and do that, and each connection has a weight, therefore must be learned by learning algorithms. So, as you see, I have talked about it, you have input layers, convolution layer, pooling layer, fully connected layers or dense layer, okay, that is what is called a dense layer. And now, we have discussed about convolution layers. Once convolution is done, it will create a lot of data, and sometimes data will be massive, that is why it has to be undersampled, that is what the pooling data is done, okay. You can clearly see that input image, then you do convolution, it can do feature maps, then pooling is done, pooling will reduce the amount of data, then you can do another convolution too, and pooling 2, finally you can reconstruct the whole image, correct. That is how actually CNN works, and this is the typical feature of that. I think I have talked about a lot of very important concepts. It will take for you to sink in and understand. Okay. Normally we use these utilities, but we never understand how these things work actually. And CNN has a far reaching consequences in material science engineering, because we handle images from optical microscope, SEM or TEM or AFM, all kinds of images. How to do this, how to do machine deep learning of these images, that requires use CNN kind of algorithms. So, we will talk about more on this next lecture. Thank you.